Okay, so the value v of a car may be modelled as a continuous variable. At time t years, the rate of decrease of v is directly proportional to v squared. So the rate of decrease of v, so in other words, how v sort of changes over time, yeah, when they mention this word rate. So the differential is dv dt, how v changes with respect to time. Now, directly proportional, so we put that fish symbol in, yeah, the alpha symbol. Negative because it's decreasing, the v curve would be sloping down, okay, so we've got a negative gradient, and then v squared, okay. So to write down the differential equation then, of course, in the equation we need to have an equal sign, so put an equals there, but have the constant timesing by it then, right, so it'll be minus kv squared. In b then, it says, look, given that v is 12,000 when t is 0, show that this is true, okay? So we need to start solving this differential equation, first of all, before we use those values, and say, look, we're going to separate the variables, okay? And as we've done before, get the v's on one side, so v squared here is on top, so take it over and divide, so it'll be 1 over v squared dv, but we'd be smart to keep that minus k there and then take the dt up. So we've got to integrate this. Now 1 over v squared, it's better if you take it up, yeah, so v to the minus 2 dv. Minus k is a constant, so when you then integrate it, you're going to get minus kt, okay, plus then your constant. Let's integrate this then as well. So v to the minus 2, well, that becomes v to the minus 1, yeah? And you add 1 to it and divide by that new power, okay? So you get minus kt plus c over here then. And let's just rewrite this a bit nicer. Minus 1, so put minus in front. And because the power is minus 1, take it down. So 1 over v is minus kt plus c, okay? So then we can think about then the conditions they give us. They say, look, given that v is 12,000 when t is 0, let's just use that. When t is 0, v is 12,000. So we put that in, minus 1 over 12,000, okay, equals to minus k times 0 for t plus c. So therefore, c is equal to minus 1 over 12,000. Okay. So next step then is to sub that back in there to get an expression, right? To try and get an expression off of v. So minus 1 over v equals to minus kt minus 1 over 12,000. Okay. And remember as well, have in mind we need to get the expression to look like that. Okay. Alright, you might be worried, you might be wondering what that a is. Let's not worry about that for a minute. It's just, it is saying there's a constant, but we'll come to that in a moment. So the first thing I think I would do is, right, let's take our time on this, but I would perhaps just change all the signs, make them more positive. That kind of makes sense, doesn't it? Okay. Yeah, okay. The next thing I would do is, you could times through by 12,000, yeah? Okay, you could times through by 12,000 just to get rid of this fraction here. So if I do that, okay, times this by 12,000, I'd have 12,000 over v. Times this by 12,000, I'd have 12,000 kt. Times this by 12,000, we'll just get 1 then, won't I? So 1 12,000th times 12,000 is just 1. Okay. Then I look at what I've got here, and obviously I need to get v on top. So what I'm going to do, I'm going to flip this. Okay. I'm going to flip this. So v goes on top and 12,000 goes on bottom. But if I do that, I need to flip this side as well. This side isn't a fraction. What I can do is write it as a fraction, can't I? And put it over 1. So if I flip this, I'll get v over 12,000. And if I flip this, I'll have 1 over 12,000 kt plus 1, okay? take the 12,000 up. Notice we got 12,000 in the answer, so V will then equal to 12,000 over 12,000 kt plus 1, right? Now, it's almost exactly like this. The only difference is they've got an A in front of the T. I've got 12,000 K. But remember, K is a constant, so that means 12,000 times K is a constant. So we can call it something else. We could say 12,000 K is a constant, so we could say let A equals to 12,000 K, right, where A is a constant. So therefore V will equal to 12,000 all over AT plus 1. Okay, so I've replaced the 12,000 K with a constant A. Okay, we're allowed to do that. So then it says the value of the car, so we're on to C now. The value of the car at the end of 2 years is £9,000. Find the value of the car at the end of 4 years. So they've given us another situation. We said, look, when T is 2, V is 9,000. And they've done that because, remember, we've got this constant here. So 9,000 equals to 12,000 over 80, so 8 times 2 plus 1. Okay. Now what I can do, another way we can manipulate this algebraically, this bottom, I can take then all the way up to the top, and the 9,000 I could take down there. I could swap. If you want me to take my time on it, I'll do it in steps. So 8 times 2 plus 1 is 2a plus 1. So basically I got 9,000 times 2a plus 1. So the bottom there I take up and multiply, goes to 12,000. Let's divide them by that 9,000. What's nice is those zeros all cancelled, don't they? And then I can get a from there. Okay, so it'll be 12 over 9. So I've got here, take that 1 over, so we go minus 1, and then divide the whole thing by 2. Okay, so if I do that on my calculator, I get 1/6. Okay, so therefore V is equal to 12,000 over 1/6 T plus 1. And then it says find the value of the car at the end of 4 years. So when T is 4, V will be 12,000 divided by 1/6 times 4 plus 1. So I'll just type that into my calculator. Okay, so 12,000 divided by that, and I get £7,200.